Welcome, students of the world and esteemed people and all of the world. This is the School of Mathematics for the Academia Hargeisa Universalis. I'm the lecturer, Mustafa Aw-Abdi, the Chancellor of Somaliland's first international online and YouTube distance learning university, based in Masala, on the outskirts of Somaliland's capital city of Hargeisa. And for the third lecture of the school, I will focus on geometry. Geometry is a branch of mathematics focusing on the size, shape, precision, and dimensions of figures in space. It covers 2D shapes, polygons, and circles, and 3D solids, dealing with area, perimeter, and volume. Fundamental concepts include points, lines, planes, and angles, often utilizing multiple proofs and algebraic coordinates. But before I begin the lecture, follow my YouTube channel for more great content. Subscribe, click the like button, write down the comments below, and ring the notification bell so you can feel good and feel like without having to worry about it. So, enjoy the lecture. Geometry is a branch of mathematics concerned with properties of space such as distance, shape, size, and ranges of figures. Geometry is, along with arithmetic, is one of the oldest branches of the mathematics. A mathematician works in field geometry is called a geometer. Until the 19th century, geometry was almost completely devoted to Euclidean geometry, which was the notions of point, line, plane, distance, angle, surface, curve, and curve as fundamental concepts. Originally developed in the physical world, geometry and almost all sides, and also in art, architecture, and other activities that relate to graphics. Geometry also has application in area of mathematics that are apparently unrelated. For example, methods of algebraic geometry involve a wild proof of Fermat's last theorem, a problem that was stated in terms of elementary arithmetic and remained unsolved for several centuries. During the 19th century, several discoveries enlarged dramatically during the scope of geometry. One of the oldest is the Theorema Egregium, remarkable theorem that asserts roughly that a Gaussian curvature of surface is independent in Euclidean space. This is why the surface can be studied intrinsically. That is, a standalone space and being expanded into a very manifolds and Riemannian geometry. Late in the 19th century, it appeared that geometries without the power to postulate non-Euclidean geometries without introducing any contradiction. The geometry that underlies geometry is the famous unknown geometry. Since the late 19th century, the scope of geometry has been greatly expanded, and the field has been split in many subfields that depend on underlying methods. Geometrical geometry, algebraic geometry, combinatorial geometry, algebraic topology, discrete geometry, allotic geometry, etc. All the properties of Euclidean space that are disregarded. Project geometry that don't consider non-linear points that not distance upon them. A finite ability that numbers concept of angle distance, finite ability numbers coincidentally, and others. Different language, does combinatorial data change, a mirror of space. I will refer to as three-dimensional space in the physical world and its model of typically space, a magical structure on which geometry is defined.